everyone, I am Christiana Malta, and for today's activity, I will be doing my first video assignment in Electrical Machines 1. Okay, so for the first problem, we have the armature of a shunt generator has 0.05 ohm effective resistance. Each brush has an effective resistance of 0.01 ohm. The terminal voltage is 100 volts, while the current is 40 amperes. What is H efficiency? So first, let's identify what type of generator the problem states. Since the data of the field windings are not given, so we will assume that the generator is separately excited. So when we say separately excited, the DC generator whose field winding or field coil is energized by a separate source. So to better understand the problem, so we will do the diagram. So it is our field coils with a separate DC supply, and this one is our voltage source in series with the resistance of the brush and the resistance of the armature, and it is our voltage of the load. So and then let's write all the given in the problem. So we have the resistance of the armature 0.05 ohms and the resistance of the brush 0.01 ohms, and then the voltage of the load we have 100 volts, and the current we have 40 ampere. And then let's note that our output is the power of the load, and our input is the power of the generator. And then first, let's find the power of the load using this formula. PL equals VL times IL. So our voltage, we have 100 multiplied to 40. So we have 4,000 watts. So it is the power of the load. And then next, we need to find the power of the generator, but then our problem don't have a given voltage for the generator. So first, let's find the voltage of the generator using the Kirchhoff's voltage law. So we will have this one, AG minus RB plus RA multiplied to IL minus VL is equal to 0. But we have two brushes, so we will put 2 here at the resistance of the brush. So let's manipulate this equation. So we will get AG is equals to 2RB plus RA multiplied to IL plus VL. And then plug the given to this equation, so we will get 0.01 plus 0.05 multiplied to IL, we have 40 plus the voltage source 100. So this 2 times 0.01 plus 0.05, we will get 0.07 multiplied to 40 plus 100, so we will get 102.8 volts. So it is the voltage of the generator. So from this, we will be able to find the power of the generator. So PG is equals to AG times IL. So our AG is 102.8 multiplied to 40, and then we will get 4,112 watts. And then, what we are looking for in the problem is the efficiency. So the formula in finding the efficiency, we have the N is equals to the E out over input, and it will be multiplied to 100%. So our output is the power of the load. So we have 4,000 divided by 4,112 times 100%, and we will get 97.27%. It is the efficiency. Okay, so for the next problem, we have a DC generator has no load output voltage of 120 volts. Its armature circuit resistance is 0.95 ohm and its field coils are separately energized. If the load is rated 2 kilowatts at 115 volts, neglecting the effect of the armature reaction, what power could be delivered to the load? Since the data of the field circuit is not available, we will assume that the generator is separately excited. So, first, let's do the diagram. So, we have here separate DC supply, and it's our field coil. So, we have here load rated. Note that the rating is not the actual reading in the circuit, but first, this 2 kilowatt here will be converted into watts, so it will become 2,000 watts. So first, let's find the load resistance using this formula. RL is equal to VL squared over ER. So our value of voltage, we have 115 volts squared over 2,000 watts. So we will get 6.6125 ohms. So that's for our load resistance. So next, let's find the load current. So let's find the value of this one. So using Kirchhoff's current law. So we have AG minus RA plus RL multiplied to IL is equal to 0. Manipulating this one, so it will become IL is equal to AG over RA plus RL. And then plug the given to the equations. We have 120 over 0.95 ohms, the resistance of the armature, and the resistance of the load, which is 6.6125 ohms. So our IL get 15.87 ampere. So from this, we will be able to get the power that could be delivered to the load using this formula. PL is equal to IL squared multiplied to RL. So 15.87 squared multiplied to 6.6125 ohms. So the power that could be delivered to the load is 1,665.404 watts.